In this video, we're going to learn a type of multiplication called the distributive property. But before we get into that, we're going to start with some multiplication that we're familiar with and then build on that. So if we were to say, what is the answer to 3 times 2? Well, you guys know what that is. It's 6. But if we were going to represent it visually, if each of these units is 1 unit long, we have 3 units this way. 1, 2, 3, and 2 units this way. And so 3 times 2 would give us 6. Similarly, 2 times 4 would give us 8. What if we had -1 times 4? Well, you know that a negative number times a positive number gives a negative number, so the answer would be -4. What if we had a side length that was unknown and we called it capital A? And we wanted to multiply it by 3. We would write it like this. And 3 times A gives us 3A. What about y times 4? That gives us y4 or 4y. The order of the variable and the constant doesn't matter when we're multiplying, but this is our more standard form in the way we normally write it. Let's look at this example. What is 2 times 1 plus 3? Our Bedmas rules tell us to add what's in the brackets first, and that will give us 8. An interesting thing happens though when we see that we are just doubling everything inside the bracket. We would have 2 plus 6. If we had 2 times a plus y, we could write it like this. Now we can't group a and y together. We can't add them like we normally would with Bedmas because we don't know what the length of a is and we don't know what the length of y is. However, we can still figure out 2a plus y's. We multiply each term inside by 2 and get 2a plus 2y. And visually it looks like this. But what would happen if we had -2 times a plus y? Well, you know that a negative times a positive gives you a negative value, and a negative times a positive gives you a negative value. So we could write it this way. If we were going to multiply x, so a length of x, by x, we would get x squared. We could also remember our exponent rules for multiplying. The bases are the same, so we add the exponents. 2y times y plus 1 could be written like this. Again, we can't add y plus 1 together because we don't know the value of y. But we can multiply through each term in the bracket by the term outside of the bracket. Two y times y gives us 2y squared. Two y times 1 gives us 2y. And that's as far as we can go because these terms are different. Exponent 2, exponent 1. We can't add them together. What about this? Negative y minus 1 times y. Because we're multiplying, this value is being multiplied by this value. We can rearrange the order of these values and still have the same result. So we could write it this way. And we can do that if it makes us feel more comfortable with the multiplying. Either way, you can multiply like this, or you could consider multiplying that way. The result will be negative y squared minus y. This is one way we can consider dividing. Here we have 2by. 2by divided by 2 will give us by. If we wanted to divide what we have here into two groups, we could think of it this way. 2b squared minus 6 divided by 2 would give us b squared minus 3. Finally, if we had these shapes and we wanted to divide them into 4 groups, we could remember that y times x means the same as x times y. So if we had 3xy plus yx divided by 4, we could rewrite that 3xy plus xy divided by 4. When we add 3xy plus xy, we get 4xy. And 4xy divided by 4 equals xy.